to chime in and let's make it interactive. Okay, there we go. All right, well, you probably heard David and myself, David, talking here, and if anybody else wants to join in, feel free. But my name's David Simonis. I'm a consultant at SEI. We do a lot of different types of consulting, but we do a lot of DevOps work. I saw that the group was sitting idle, and so I took over ownership of the organizer role and just trying to get us back up and going again. And so I want to make sure that you know, we keep the group active and we provide content and information that's going to be meaningful to the larger group. So we're going to have some speakers from AWS soon, from some other technology consultants, but we've got Dave Gorin with us tonight. And Dave, I really do appreciate you taking this first one for us here, and interested in hearing what you have to say. And I think the topic sounds incredibly interesting, but we do have some upcoming events for those of us that are here. April, we've got a session led by Vlad. I'm going to butcher his last name, unfortunately. Hybrock from AWS. He's going to, his was everything you wanted to know about Kubernetes, but we're afraid to ask. And then in May, we're going to talk about Daniel Brown from Improving is going to give us a talk on 60 minutes to AWS mastery. So, Dave, I'll give you the presenter role and let you go to town, and we'll go from there. Did we lose you, Dave? Can everybody hear me? Is it my connection?
Yeah, Dave looks awfully still.
He's deep in thought right now. We'll give him a minute here. There we go. Dave, you looked incredibly deep in thought there for a minute, so you froze up then. So anyways, the floor is all yours. I'll let you present, and you've got the floor.
Thank you. Hold on, I'm trying to share my screen here. Having some challenges. We'll see if that lets me share. Oh, okay. It says I'm sharing now.
Yep. I see your teams. I see. Well, now I'm not seeing anything now. There we go.
All right. Let's see if we can get this actually going here. All right. So why you guys wanted to know about EMU bone structure, I do not know, but you know, I'm a consultant. I do whatever I'm asked to do. Wait, what? Oh, immutable infrastructure. Sorry. All right, so immutable infrastructure using Git, Jenkins, and Terraform. So who's this David guy, and why are we talking about emus, or I mean immutable infrastructure? Give you a quick introduction to immutable. Why things you need to do to be able to do it. The infrastructure pipeline and what it looks like and why that's good. I'll walk you through the major setup steps, and then we'll have questions and an open discussion. As the Dave said, I don't mind if you just want to jump in immediately and ask your questions. Don't feel shy about just asking something. Okay, in the middle, or you can wait to the end, whatever works best for you. Okay, so why I actually know what I'm doing. So I'm a senior architect for Talos, which is now an IBM company. I've been hands-on doing this kind of work for 36 years. I'm a developer and an infrastructure person. I have 6 certifications. I'm also a subject matter expert for the actual exams. So, and no, you're not allowed to ask me about them. I've been in cloud for 11 years, 7 in AWS. And I've done this in a lot of companies because I've been a consultant or full-time architect of companies doing this since 2014, basically. Okay, what is immutable infrastructure? And this is my favorite description of it, no touchy. Once you deploy something, that's it. You don't log into it, you don't manipulate it, you don't apply updates to it with Chef or Puppet or Ansible or any other thing. You literally don't touch it. There's a lot of good things about that. It also makes for things you have to do, right? So it's not trivial to set that up. All right, why is immutable a good thing? A lot of things that you get stuck with, both for exposure for security and for just grunt work, simply don't exist anymore. So you never patch the OS. So if you take a company like Netflix, Netflix literally just has an instance that lasts 4 days, period. And that's it. And then they kill the instance and a new one is created. So they never worry about being out of patch. They never worry about being anything because the latest always gets deployed every 4 days. And they do it in a rolling, by the way, they don't do them all at once. But the advantage is there's nothing to do beyond creating a new machine image, which is in their pipeline as well. Dave, there are people waiting to be let in.
Yeah,
Can
I keep admitting them as soon as I see them.
Oh, okay. Good deal. All right. The other thing you don't have to do is you don't have to worry about dependencies, because if you build your AMIs with your dependencies in them, or you have a startup script that's loading your dependencies, like in an auto scaling group, or even if you're using something like Ansible, then you never have to worry about having the latest Java, the latest Python, the latest library of this, that, and the other thing, because it's part of your actual infrastructure. Okay, now here's where the security things come in. I've spent a lot of my career in finance or working for three-letter agencies for the federal government or companies that are planning to work for the federal government, three-letter agencies. And so there's a lot of security controls, hundreds and hundreds, that you have to deal with. And by doing immutable infrastructure, you bypass a huge number of them, because once something's deployed and it's gone through your pipeline and it's been validated in your pipeline, now it's on. Now you don't have to have all the security controls of who's allowed to log into it, who's allowed to apply a patch, who's allowed to authorize a patch, ... That's all gone, which is a tremendous advantage when you're trying to go for compliance, to get away from all of that. Being able to track people connecting to instances and doing things. You don't have to do any of that because no one can do it. So this is one of the things why Immutable is just a wonderful thing. Okay.
Hey, Dave,
Like I
have
said,
a question. This
sure.
is Pat. Do people give you or give a hard time to this for not applying? Let's say a 0-day came out and there's patches now for it, and that really should be applied, or is it something that you just patch the next version and then roll it out sooner?
Most SLAs on 0 days, even things like that, tend to still have a few hours. And what you can do in an immutable environment is you just go out and start killing instances. So you do like a phased deployment simply by killing things off and letting them getting recreated. And so it's still like doing a 0 day, but it's not in place patching. You create a new AMI with the patch in it and deploy it through your pipeline. And then you just, run a Lambda or run a script off the command line and just start killing instances so that the patched ones come up. Okay. So you have the same method, the same concept, but different method. Okay.
Cool. Thank you.
Sure. Okay. This point also about the deployment happening through a controlled pipeline. Because of the pipe, and the advantage to that is, again, if you're going to be in some type of compliant environment, or even Deloitte staring over your shoulder, and I've been in that scenario before, where they're not going to any particular standard, but they hired one of the big five to to make your life miserable. Having a controlled environment like this, again, bypasses because verify the pipeline, and now you don't have to have like this huge audit of 300 users, which is the kind of thing that happens in other companies. One of the other things I love about infrastructure as code is you can recreate anything quickly. So things like QA environments, I never even leave them running, right? You use them and then you kill them. And then when they want a new one, I just create a fresh one from production and not bother with trying to figure out what's changed between, the last time they used it and today. So it makes environment management very easy. Same thing with dev environments. So you just stand up a copy of something very quickly. Now, keep in mind, it takes work to do this. It's not fun, but it does have an awful lot of benefits. Okay, some of the things you have to do if you want to do Immutable. You have to have a code strategy because infrastructure as code, because of how damaging it can be to your environment and the fact that it's fairly short, right? Code's not very long. Scripts that deploy infrastructure, like a program, they're very short. So having a good tagging, a good strategy for your source control, like Git flow, right? Or feature branch or whatever it is that you want to do, you have one and actually have good processes with your people to actually use them. And one of the problems with DevOps personnel is they're not very good at that kind of thing. And, and I joke because I came from the developer app architect side of the world and then went infrastructure. I think developers make better DevOps than DevOps coders. It's actually pretty hard to teach code to DevOps personnel. But developers actually pick it up rather quickly. So it's kind of interesting because they actually consider it easier. Having a good tagging strategy. Why do you need a good tagging strategy? All right, I used to work for a giant company that might provide all the weather data for most of the planet. And they had thousands and thousands and thousands of instances running at any one time. Literally 8,000, 9,000 instances was a normal day. Not knowing who owns something or what it's for makes it really hard that when you have a problem trying to track them down. So having a good tagging strategy of who owns something and what it's for and whether or not it's long-lived or short-lived is a good thing to have. So having a good tagging strategy, and actually AWS is a great document on a good best practice tagging strategy. And I've actually used theirs to present to clients, which is kind of funny because they could have just downloaded the document themselves, but neither here nor there. Centralized logging. Did my share just drop?
Microsoft Team pops up to the front, so I'm seeing myself. There we go.
Oh, okay. So centralized logging. Because you can't log into an instance, you have to have something running that centralizes your logs. And if you don't, you can use CloudWatch. CloudWatch agent's not bad. For sure. I was at, a giant company here in Atlanta that might make a lot of sugar water. And we were using the CloudWatch agent and it worked great. And we were using it for all their freestyle machines and all their mobile apps, and it worked fine. So, don't feel like you have to run out and spend money for Splunk. Splunk's a great product, no question. It is horrendously expensive. And so it's not an easy thing. If your organization is short on cash, that's not where they're going to spend their money. Standing up your own elk stack, it's gotten a lot easier now that there's a managed elk stack in AWS. But it's still work. You still get to do it all yourself, right? So if you stand up managed Grafana or managed Prometheus or managed Elk Stack, yeah, it works great, no question. But then you're going to have to dedicate someone to take care of it, or at least a certain amount of their time to take care of it. Personally, I think if CloudWatch is good enough for you, use CloudWatch. If you need something a lot more sophisticated, either dedicate the personnel to do it. Elk or pay for something like Splunk. Okay, this next one, this is the furball, especially if you're in something like a bank where they've got apps that are older than the hills. They don't lend themselves very well to being recreatable via code. I'm dealing with an app right now called Teller Insight at a giant bank, and it literally configures by hand on Windows. There is no automation at all. And so setting that thing up for Immutable is next to impossible, because the only thing I can do is spin up an instance, snapshot it, and then restore that snapshot. There's no way to program building out a new Teller server or a new Teller client. It won't work. We've been fighting with the vendor to try and have them help us, but that's the kind of thing that will make Immutable infrastructure tough. When you have an app that literally is really old school and has no capability of being configured via code. Okay, this next one.
Are you doing exactly what you just said, where you're spinning up one image, installing it, making a snapshot, and pushing that out?
Yep, that's exactly what we're doing. And then when we copy it to another region or another availability zone, or it's a different environment, we go in and make like the minor config changes that are in the registry or the config files. It's a Windows app.
Yeah,
to
I used to.
Make it work, which is bogus and not supported by the client, but we're desperate because, you know, I mean, we're in AWS. We can't be sitting there hand configuring clients and servers.
Yeah, we had to do something previous where I used to work, where we did a private cloud network for CPA firms, and they had so many legacy apps, and trying to roll out images with the apps auto installed, that we had same problem. So just curious.
No, it's tough, and that's a big stopper for a lot of people going to Immutable, is the fact that you get these apps that are incredibly painful to maintain because they were never meant for cloud. They're meant to be long-running instances, right? They're pets versus cattle, and you know, they're very stateful, so you can't auto scale them and things like that. And you know, with those, you're stuck. You can do the best you can with a snapshot and an AMI from that snapshot, and that's about as good as it's going to get. I did add for one of the ones I'm working on right now, which is another legacy app, that the new FSX server for Windows service that AWS has. It gives you that cross AZ and cross region capability without you having the app think that it's anything more than one volume. So it's giving me that kind of cross-region synchronization capability and cross-AZ synchronization capability that the app itself doesn't have, because it's literally a single instance with a single attached RAID array on-prem. And being able to move it to that is a real advantage for me, because now I can create an auto-scaling group of one with a machine image of that machine, and then that lets me go across AZ and across region for failover and high availability, which of course it doesn't have now because it's just one server. So yes, you end up doing these really tricky, bizarre, crazy things to try and make that kind of stuff work. And all I can say is, you know, I'm happy to help you if you've got one like that. But, you know, a lot of times you have to be really careful because the vendor might not support it if you do it that way. So you have to be very careful. And especially if you're doing something like I'm doing, where I'm working for this giant bank and we're dealing with real money, there's quite a bit of exposure. Okay. Now, this next bullet, this is specific to Terraform. Terraform maintains a state file. What a state file is basically a gem that describes what it thinks the environment looks like. And, you know, if you do things via Terraform, you have to do everything via Terraform, because if you go and make a manual change, Terraform doesn't see that change. And when you go and run your Terraform again, it'll wipe your change out. Okay. And it stores it in that state file. Those state files are normally in S3 buckets, either one per environment, or you just have it like a centralized account where you do everything and you have one bucket that has all your S3 files. Now, again, talking about the giant company that might produce a lot of weather data, they had one state file for the entire environment. So an apply would take about 5 hours. And the reason is that it does a diff between what you're trying to do and what that state file thinks the environment looks like. And if you do that for 9,000 instances, it's going to sit there and grind. So the goal is when you create things like modules in Terraform or CloudFormation is keep them small, keep them down to just what you're doing. So if I'm just doing subnets, I have an entire repo or folder that's nothing but subnets, like VPC and subnets. If I've got one that's spinning up an EKS cluster, it's just that one EKS cluster. And the advantage to that is now people can do other work and update other resources and not crash face first into what you're doing because you're only updating the one small part. And things like VPCs and subnets don't change very often, right? So the advantage to that, of course, is that now, you know, your big ones are fairly static. And then people then can build out their own environments with their S3 buckets and their RDS and their auto scaling groups or their EKS clusters, whatever it is they're doing. It keeps it small. Okay, this next one. This is an interesting one. And I've hit this 3 times in a row now. Every time because we were doing 3-letter agency. So the disadvantage of Immutable, obviously, is that if something really does go pear-shaped, you might actually have to log into something or look in the database. And you can't do that in an immutable infrastructure because there's no way to access it from the outside, right? That's the whole idea. So what you end up doing is you create like a tools AMI that has things on it like your SQL query tool and, you know, whatever log analysis tool you have or whatever, you know, configuration management tool you have that's, you know, unique to whatever you're doing, which, you know, might even be your own scripts, right? It's not, doesn't have to be anything sophisticated. What you do is you put it on an AMI that's not running as an instance. And then when you desperately need it, you spin it up, they do their work, and then you kill it. And the advantage to that is auditors will look at that and say, well, it was only up for 30 minutes and it was inside your environment and only, you know, these 2 people could get to it. So no harm, no foul, right? As opposed to having a tool that's up all the time and is available to your entire DevOps squad or your entire support team for a particular app. Now you're in an entirely different environment of having to keep track of things. So it's one of those good things to do that in hindsight I ended up having to do. Would have been great if I'd done it up front in some of these other environments. Okay, harden Jenkins. I can't tell you how many times people don't do this. All right, Jenkins spins up as a single instance unless you tell it otherwise. And I've spun them up. I have one running right now in my personal sandbox account. Well, if all of my infrastructure and all of my code are deploying through Jenkins and it goes down, I've now cut myself off from my entire environment. So if you're going to use Jenkins or any other CI tool, you do have to do a fault tolerant, high availability one, and it has to be connected to whatever your default authentication mechanism is. By the way, that's another good thing for Immutable is having centralized authentication, whether you're using Active Directory, which a lot of people do use. I've done simple AD and managed AD inside AWS, which work quite well. And I've also done it with LDAP, and it does work. So, you know, again, that's one of those things that you want to have as part of your strategy is to centralize that. Because it also lets you do things like shut off a user if they leave, right? Or a set of credentials gets loose in the wild, which we won't talk about how often that happens. All right, what's this pipeline actually look like? So here's a fancy version. This is actually HashiCorp's version of best practice for using Terraform in a CI/CD pipeline. And if you look at the far left, There's your source control, which happens to be Bitbucket Cloud in my case. And I don't have the Slack integration running, but so DevOps actually downloads the code for whatever it is to their local environment. They edit it in editor of choice, right? VS Code seems to be the most popular one right now, but I've seen Atom and quite a few others. So it's like whatever works for you. Jenkins is the actual thing that runs the jobs, and Jenkins has plugins for Bitbucket and GitHub and everything else. And it also has plugins for Terraform. So then it actually fires up a build agent. And if you're running on one server, the agent's actually on the same server as Jenkins. Normally, it's not a scaling group, or if you're running it in EKS, it's just another set of containers running inside the EKS cluster. And what it'll do is it'll run Terraform. It'll create a plan. And a Terraform plan is basically saying what I'm about to do. So it's kind of the diff between what you're trying to do and what the current environment actually looks like. And then it applies it, and it writes the result back to Jenkins. And then, lo and behold, you get infrastructure. So now I'm going to show you some of it. Unfortunately, I was not able to get my end-to-end pipeline to work. That day job got in the way. But to give you an idea of what it takes to set this up. So I installed my Jenkins, and all I did was follow the directions. And I'll list my email at the end, and anyone who wants to see the gory details, I will send it to you. Okay, so now you're in my Jenkins, which I literally have running. Let me show you something about this first. So you see, here's my Jenkins server, right? And it's just a basic Amazon Linux instance, right? Which happens to be CentOS 7. I think it's 7 now, or is it 8? I don't know. It's system control, so it's at least 7. But if you look at security groups, here's an important concept. So here's my Jenkins security group. What are all these IPs? I actually labeled this first one wrong. Oh, it's upside down. Okay. Atlassian tells you all of the output IPs of Bitbucket Cloud. GitHub has the exact same thing. So if you're using either one of them, you go look it up on their site, and they will tell you what their outbound IPs are. And you see I've whitelisted them. The reason being, if I'm going to put a webhook in so that basically Bitbucket or GitHub can call a run that deploys into my infrastructure, I want it to be tight so that nothing else can get to it. And you see the only other one that can get to it is my personal IP address. So the advantage to that is, of course, is that even if I completely bollocks up security somehow, you would have to be in my Bitbucket or in my personal Wi-Fi to even be able to get to the Jenkins server. So this is something a lot of people make a mistake on. I can't tell you how many places I've been where people have left things 0000 because they're lazy. I can tell you right now that a certain place here in Atlanta that might make a lot of chicken, one of their enterprise architects posted out a Rundeck instance, didn't know there was a default user on it, did it 0000. I got a call from AWS that people in China were using his Rundeck, and they were going to shut his entire account off, meaning all of Chick-fil-A, if he didn't get rid of it. So even though it's tedious to do something like this, don't pass it up. Good thing to do. So if you look at my job, and this is the part I hadn't finished yet, what you end up doing is you pair a branch in a repo in your Bitbucket so that when a change occurs, it knows to trigger that job. And so if you look at my repos, here's my infrastructure as code repo. And if you look at branching. Let's see, I'm trying to remember where this goes. I think it's pipelines. No, I take that back. It's in branches. So there's a webhook in the branch that gives it the URL of my Jenkins server so that it knows to call that Jenkins server when a commit happens to this master branch. And I can't remember where it is. I'll have to find it. But then from there, it would find whatever job is related to that same URL path, right? So using the master branch as your production is not a bad thing, right? Or you can use it as your latest dev. Either one works. But the reality is that as soon as you do a push to it in Git, it triggers this job. And then by triggering the job, then you would see that in Jenkins, I have, assuming it'll respond to me. So you see I've got Terraform configured. And then if you look in plugins, you will see that I've got Bitbucket installed, so it knows when Bitbucket contacts it, it knows what to do. And I have Terraform installed. Now, one of the things I love about Jenkins, there's tons of CI/CD tools out there, tons, and some of them are better than others. So for things like doing Lambdas, AWS code build is better than Jenkins by far, because you have to do elevated privileges in Jenkins, and a lot of security people hate that. But Jenkins is kind of the Swiss Army knife of CI/CD tools. It has a plugin for practically anything you've ever heard of in your life. And the advantage to that is you don't have to figure it out. You load Jenkins, figure out whatever plugins you need and stuff them in there, and off you go. And that's one of the reasons why Jenkins is still so popular, even though there are native tools in GitHub, there's native tools in Bitbucket, there's native tools in AWS, there's native tools in Google, and yet I can tell you that in all the places I've worked, 99 times out of 100, it's Jenkins, just because it is the easiest to configure for any scenario you can think of, with very few exceptions. So that's about as much as I have to show right now. Like I said, I will show the gory details of the full configuration if anybody wants it. I am going to do a production grade version of it, because that's one of the things that I hadn't done here. Like I said, I didn't do the full HA, and I didn't do security. I did a local user and running as admin, which of course is a bad thing to do. That's the other reason why you have to be so careful. In order for any system to be running Terraform, it basically has to have admin privileges to your entire environment. Otherwise, it can't build. Even if you just, all the scaling groups and EC2 and so on and so forth, it still has admin privileges to those particular resources. And therefore, you can destroy things, change things, spin up Bitcoin farms, which, by the way, has happened more often than I care to mention about companies I've worked in, where someone gets access to their Jenkins server and spins up an entire environment for Bitcoin mining. So just one of those crazy things. All right. My contact information is at the bottom if you want to actually get in touch with me directly for anything else. And floor is open to discussion.
Thanks, David. So if a company wants to make a change and go to a more immutable infrastructure, I assume it's something you can kind of do and start in a kind of hybrid approach where you start tackling certain servers at a time, or what would your approach be if somebody wanted to make that change today?
I've done this a lot, and I can tell you that you are correct. What you end up doing is you get your pipeline in place, you get your processes in place, and then you start with the low-hanging fruit. So you take the app that's already a microservice and it's EKS or something like that, and then you build that one completely out, right? And then you get your SSO in place, and then you know, because obviously this is a company kind of philosophy change of how you do things. And so we've really found that you kind of like get all the mechanisms in place. And one of the things I didn't go over, which is something I do a lot now, is putting scanning tools into the pipeline for code, for infrastructure as code, just as well as you would do it for code for an app. So, you know, like in an app, you'll run SolarWinds and Twist Lock and, you know, all these other things that you can run. Well, there's a lot of tools for infrastructure now. So there's HashiCorp Sentinel, there's Dome9, and, you know, OPA, which is open source product, right? The open policy agent. And you can put all of these things directly into that same Jenkins pipeline so that I can put guardrails around you so you don't deploy something stupid, right? Like an instance that doesn't have whatever your antivirus installed on it, or doesn't have your logging agent installed. You know, making it so that, you know, you can't spin up, you know, a 55 node Aurora cluster, you know, things like that. And so it starts to get sophisticated, and then you begin to onboard all these apps. But then, you know, as Pat had mentioned, Pat, certain apps are pathetic and they take a lot more work to be able to make immutable. But the reality is, especially if you're doing new development, you're actually doing something that's relatively, you know, horizontally scalable and relatively state controlled. It's very easy to make it immutable.
In terms of cost, and do you find that there's a cost savings to immutable infrastructure just due to the fact that less cooks in the kitchen, or less people needing to go out and do stuff on a regular basis? Or is it no real cost savings? It's just some of the other benefits we talked about earlier.
You do get a lot of benefits because you don't have a whole patching team. You don't have a lot of your DevOps people tied up doing manual stuff. And let's face it, DevOps people aren't cheap. You know, I mean, they're expensive, whether it's third party or internal, they're not cheap dates. So having them actually working on new stuff is far more cost effective than them patching servers and standing up dev environments and standing up performance environments. So when you're in infrastructure as code and you're immutable, you know, for me to stand up a performance environments, you know, run the Terraform and wait 15 minutes, you know, as opposed to a 6-day job for someone to manually spin that whole thing up.
Sure.
It also cuts your error rate way down, because once you get your Terraform right, that says, this is my company standard EKS cluster. And then, you know, some are bigger, some are smaller, you know, whatever, because of your pods or its development versus production. Well, I'm only changing two little things, two little variables in a TF-vars file, and then running it. Whereas if I manually configured it, the odds of me dorking it up get to be very high, right? So that's the other thing. As soon as you get stuff that's repeatable, it starts to become a lot less effort to stand things up and take things down. And then you start getting into the things where you don't leave things up and running. I don't leave QA environments up and running. I refresh dev environments on a regular basis. And the advantage to it is, again, I don't have to patch. I don't have to worry about it being out of date. I don't have to worry about it being out of sync with prod, because I'm using the exact same code. And all I'm changing is the VPC and the subnets and the sizes. And then off I go.
Yeah.
And the advantage to that is tremendous. And again, through a pipeline, and I can monitor that pipeline, I can stop people doing stupid crap. So it also lets me make things a lot more self-service, right? So I'm working on a pipeline right now to generate AMIs, and we're doing the golden images first, right? So the 3 images that the whole company uses for everything, 2 Windows, 1 Unix. We're scanning it, all that. But you know, that's great. We're just imitating an existing process. The next step is we're going to put Spinnaker in front of that and say, now you can take that golden image put whatever you want on it. I'm going to use OPA to scan it, and then you can create your own machine image. And you don't have to ask DevOps. You don't have to ask anybody. You log into Spinnaker, and if you have the rights, you can go ahead and generate your own AMI. And so the advantage to that is now my DevOps people are not tied up generating custom AMIs for 24 teams who may not know what their AMI is supposed to look like. So they're going to do 6 of them before they finally get to the right one, or 12 of them. I mean, I can tell you right now, the first time I did EMR, I must have spun up 13 of them in a row until I got one that actually worked the way I wanted it, right? And the advantage of cloud is I could spin it, kill it, spin it, kill it, spin it, kill it. Well, being able to give that directly to a dev team and not tie up my DevOps staff to do the exact same thing, that's magic, right?
Yeah.
That's the fun part. So there is kind of a lot of upfront effort to this, but the payoff's enormous. And then, of course, if you're in an environment where you're going to get audited, this is gold, because nothing makes them happier than showing that you've got guardrails around all the critical stuff, right?
Yeah.
Because to retroactively go back and do this, which I have done, is 5 times more work than if you do it up front.
Anybody else have any questions?
Yeah, I'm a developer, and a question I have is, what are the principles that you would give to developers so that things can be done using an immutable infrastructure? What are the characteristics that have to be in the applications for that to work?
Mostly for an application, the most advantageous is when your statefulness is not part of the app itself. So if you can put your statefulness in Memcache or Dynamo or Redis, then it's very easy to make a scalable, immutable, recreatable infrastructure of your app. If your app's really stateful, that gets hard. It's still doable. You can turn on stickiness. There's a bunch of other things you can do, but it gets a lot harder because you actually have to have things like shutdown scripts and bleed connections from one server to another and things like that. Still doable, and I have done it. When I was at Fabric.com, which is actually a subsidiary of Amazon, they had that. Their app was very stateful. And what we had to do is we still did the exact same thing, but we had to put in session bleeding so that you couldn't roll an instance until all the sessions fled off of it. So it's a little bit more work, but it's still doable.
Thank you.
Mm-hmm.
A different question that I have is related to something that you said during your presentation. And the gist of it was your data is all within that cloud, within the immutable infrastructure. And that just blew my mind. How can that be if you have state? So can you talk to that, or what does that mean?
Okay, so the actual contents of a data store has nothing to do with the data store itself. So say I decided I was going to use Aurora, and I've used Aurora a lot. So I moved the retirement portal for all of state of Florida to the cloud and moved from Oracle to Postgres to Aurora at the same time. So the immutable part is the configuration of the Aurora database, not the contents. So the Aurora cluster is the immutable part. The data is mutable. So you still have to have backups. You still have to have, a replica in another region or whatever that is that you're going to do for your DR.
Right.
But the actual infrastructure of the RDS is immediately recreatable at any size, anywhere I want. Now, the loading of the data into it, that's still native to whatever that data method is, unless I'm restoring from a backup, right? An Aurora backup.
Okay. So a problem that I've had in the past, it's unrelated to the immutable infrastructure, is basically schema evolution. Back in the days with relational databases, you add 20 capabilities, it required 20 schema changes, and it's okay to roll forward. You've written that, but in order for this to work, you have to also write the rollback. How does that work for Immutable?
You pretty much hit it on the head. You can do it one of two ways. You can either have a rollback so that you can restore the prior state via backup or via, whatever rollback process you want to use, native to the database type. But if you're really going immutable, you'd create a new table each time, and then you would deprecate the old tables.
Yeah. So now I haven't done it, but what I'm guessing is that if you're writing things in an immutable way, you really sort of design it differently. So you sort of avoid schema change in the true sense. And, the NoSQL databases make that type of stuff easier. Is that more common, to use Dynamo or Redis or something like that, where you can just create basically name table values, name key value pairs that you just change the way you're implementing it?
What I've seen evolve over time, because I started with Dynamo when Dynamo came out, right? So, and I worked NoSQL long before cloud. I used to use a Versant object database. So, I was in this way long ago, back in the day, for telecom, which was super high performance. Is that you end up using the NoSQL database as your persistence store, whether it's Mongo or Dynamo or things like that.
Sorry
to
interrupt, but it broke up. You right when you were saying you would use, and then could you repeat that again?
Oh, okay. So you use a NoSQL as your persistence store, whether it's Dynamo. So let's use Dynamo as the example. So the great part about Dynamo is you can add a field, no problem, right? Because it's really just a JSON structure, right? So what you end up doing, though, is if you need any of the SQL type capabilities, like being able to do a join or being able to do a table scan type query, those are terrible things to do in a NoSQL database. So what you end up doing is we create indexes in a SQL database. And in the indexes, we just create the fields that we want indexed. And then it's just a pointer into the record in the DynamoDB. And the advantage to that is it doesn't move nearly as much. Right. And you can rebuild the whole damn thing from scratch if you wanted to, because the Dynamo content's still there. And that ends up giving you your cake and eating it too, right? So that, especially if people are using like BI tools and things like that that don't really respond very well to NoSQL, it gives you that advantage. Now, sometimes if the tool's dumb enough, you end up having to like dump the whole thing into Redshift and just synchronize Dynamo to Redshift and basically end up with two copies of the data. But it gives you those two views that you need. So like if somebody's running, whatever SAP business objects, whatever they keep renaming it, right? Used to be Crystal Reports. It can't tolerate a NoSQL database. So that's where you literally just dump it into something like Redshift, which can respond to a regular, SQL type connection and give you that behavior, right?
Interesting. Okay, thank you.
But your source of truth is still Dynamo.
That's all I had.
Okay.
Anybody else? I'll take the crickets, meaning no. Well, thanks a lot, David. I will try to post this out on the group, and I really appreciate you jumping in and helping us get started. And like I said earlier on the call, we've got our next meetup coming up soon. In about a month, we're going to start with monthly, and then we might try to build in some bi-weekly meetings here and there as we have, if the interest grows. The next one being presented by AWS on Kubernetes. So hope to see you all back then. And if you have any questions, feel free to reach out to myself Dave had his contact information. David, if you want to put it in the chat as well, that might be good, just in case somebody wanted to reach out to you and can't find it in the presentation somewhere. And then definitely reach out to myself if you've got any questions or comments about the group, and we'll go from there. But I really appreciate your time, and I appreciate everybody attending tonight.
Yeah, thanks for doing this.
Sure thing.
Take care, everyone.
Thank you.
All right. Stay.
Bye.
Bye, everyone.